This is going to begin our lecture series on Lagrangian optimization. And what we're going to do is we're going to transition from using indifference curves over to using mathematical equations. So just like we did at the start of intermediate micro, we used supply and demand graphs, and then we transition into using algebraic equations to try and represent those functions. We're going to do that same thing here. We're going to take indifference curves, and then we're going to use some math to represent those indifference curves. So in this lecture, what we're going to do is we're going to go from indifference curves into demand curves on a traditional supply and demand graph. And then we're going to see how that ties together. And then we're going to transition that into the mathematical functions. And we're going to move into setting up what's called Lagrangian optimization. So we can see here that we have this price and quantity relationship when we do standard supply and demand, right? When we do traditional indifference curve analysis, we actually have two quantities. We have a quantity of y and a quantity of x. How do we get from two different quantities to a graph where we can show the demand for one of these goods, where we can show price and quantity? That's really the question that we have here. Well, let's look at a scenario where we're showcasing an indifference curve, and we have two goods, x and y. And we know that we have an income of 100, and the price of y is 10, and the price of x is 2. Now from this, we can draw up our budget constraint. So we can see here that we have the budget constraint. We will be able to consume at most 10 units of y, as the price of y is $10. So 10 times 10 units would give us our total income of 100. Or we can consume at most 50x. The price of x is just 2. If we get 50 of them, we would spend our entire income, our entire budget of $100. So we can see where we have our budget constraint here at this point in time. Given this budget constraint, we can see where our hypothetical indifference curve would hit, where the indifference curve would just kiss the budget constraint. This would be our optimization point, and we could see our theoretical consumer consuming this much x and this much y. Now, what we're going to do in this example is we're going to look at x specifically. We're going to try and create the demand curve for x. And so we've drawn up our budget constraint, and now we've put in our theoretical indifference curve. And so what we can see here is that when the price of x is 2, we consume 35 units of x. So we could translate this to our supply and demand setup. So notice here we have price and quantity, not two different quantities. So we're transitioning into our supply and demand setup to draw our demand curve. We have only one point though. We only have that at a price of 2, we consume 35 units. But that is coming from our indifference curve analysis. The next thing that we could do is take that exact same setup, but now theoretically change the price of x to 4. This will just kind of shift around our budget constraint. It'll twist it. And so now our budget constraint looks like this purple line here. So we have this new budget constraint that has come in. What has happened to our budget constraint is that it has just rotated. We still have the same price for y and the same income. So if we purchase absolutely no x and all y, nothing really changes. Right? So we're still at this same point on our red budget constraint, the original budget constraint, and we are on that same point with this new budget constraint here, as we have not changed anything to income or y, but we have changed the price of x. Now the price of x is 4, our income is 100, so if we spent all of our money on x, we would end up at a point where we consumed 25 units of x. So we simply connect those 2 points and we get this new budget constraint here. Now mind you, this is the budget constraint when the price of x is 4, right? Originally, what did we have? We had a budget constraint when the price of x was 2. And so now we're looking at a different budget constraint, a different price of x. And what happens when we put our hypothetical indifference curve on this budget constraint? Well, we could imagine that it changes the optimal quantity And in this case, the optimal quantity of X drops to 15. And so now what we can say is, we also know that when the price of X is 4, that was what happened when we changed that budget constraint. We just changed the price of X to 4. That was the only thing we changed, so everything else was held constant. The quantity of X changed to 15. And so now we're starting to get what looks like a demand schedule or a demand curve. We're getting multiple points on our supply and demand for X. And so with just these 2 points, we could theoretically construct a demand curve just by connecting these 2 points. But theoretically, we could fill in all of the other points at various different prices of X as well. So one thing we've done is we've derived our demand curve from indifference curve analysis. But another thing that we've seen is that we can get a demand curve from indifference curves. And we know that demand curves can be shown or represented as mathematical equations. So we have this link between the mathematical representations, the demand curves, and indifference curves. So we can show these mathematical representations of our indifference curves as well. We can show mathematical equations that represent our utility. So we're going to turn towards analyzing consumer behavior with this mathematical approach, and we can see how it's built off of the indifference curve foundation that we have been studying. To move on in understanding Lagrangian optimization, up next we're going to cover unconstrained optimization. So now we've gone from indifference curves to our supply and demand. From supply and demand, we know that we can tie this into our mathematical approach. And so we're going to bring all of our theory of consumer together and start talking about Lagrangian optimization.